Dear students, we were discussing the dipole moment, how the 1 hour scatter rule is used to find out the conformation. Then we also discussed the dipole moment and the strength of acid is a clear-cut theoretical concepts, and by using this concept you can find out the conformation of a molecules. Okay, we have one example. There is a 1,2 cyclohexane dicarboxylic acid, and the question is like that: if there is a cis isomer, the difference between two pKa values are 2.42, and if there is a trans, difference between two dissociation constant is a 1.75. Now the compounds, when you draw the compound is like that. Our first compound and second, that is a trans. Okay, this is the trans one. Okay, opposite, these two groups are the opposite, trans. Okay, 1,2 cyclohexane dicarboxylic acid, and second one is our same side compound. One is COH is the same side, also other COH is the same side. Okay, there are two carboxylic acid groups present in this molecule. Therefore, this molecule have two dissociation constant because it dissociates twice. First COH group gives the H plus ions at first dissociation, and at the second dissociation other COH gives the H plus ions. Therefore, it is has two dissociation constant. Therefore, first is your pKa first and pKa second. And in this also, that is your trans isomer, 1,2 trans. Trans is COH group is away from each other, and second is the cis 1,2 cyclohexane carboxylic acid. Therefore, we firstly clear that there should be two pKa values. Okay, in this case also there is a 2 pKa value. The difference between these two pKa's for this case, cis isomer is 2.42, and for this isomer is a 1.75 pKa. Okay, therefore large difference is found when there is a cis isomer is there, and small difference is found when there is a cis isomers. Sorry, for the cis isomer your difference should be 2.42, and for trans isomer your difference should be 1.75 pKa. Firstly, we have to clear that. One concept should be clear. What is the meaning of pKa? pKa is a value which gives the strength of HCl. The strength of strength of acid. The strength of acid is inversely proportional to the pKa. If pKa value is higher, then the strength of acid is the higher. Strength of acid higher means what? The strong acid means what? Strong acid means it dissociates easily. It gives dissociation means what? If there is an acid and which contains COH group, and it dissociates that hydrogen, you use the CO minus and H plus ion. This is called as a dissociation of the acids. If your acid easily gives the H plus ions, that is your strong acid. And this carboxylate ion is called as the conjugate base of that particular acid. This is acid and its conjugate base is this. And for this base, conjugate acid is COOH. If it easily dissociate, easily give the H plus ion, 100% or 90%, 95% give the H plus ions, that particular acid is a strong acid, easily gives the H plus ions, and that dissociation it dissociate easily give the H plus ions means what? It dissociate easily. It dissociate easily means it is a strong acid. If it is a strong acid, pK value is the less. Remember, strong acid pK value will be less. If a weak acid, pK value is the is higher in quantity. Okay, this is directly inversely proportional. pK is inversely proportional to the strength of acid. Now, why it gives the H dissociate easily? Why? The question is why dissociation easily when your conjugate base is the stable one. Remember that. If your conjugate base is the stable, then dissociation of acid can be easily happen. If your conjugate base is the unstable, then dissociation of acid is very less in quantity and it is a weak acid because its conjugate base is the unstable. Therefore, when conjugate base has the stability, then your acid is strong and pK value is also less. Okay, this is the one of the relation of the pK with the acid. Why the acid is strong? Because its conjugate base is the stable base. Therefore, in this case, we have to explain why in cis isomer your difference between first dissociation and second dissociation is 2.47 and for the trans isomer it is a 1.75. Why this difference is occurred in this molecule? I have the question. This answer can be given, this answer is situated in its conformations. Where is the position of COH group? This answer is situated in the position of COH. Suppose we side by side discuss these two molecules and try to explain why there is a such kind of difference is observed. We have the first molecule is cis molecule. Remember, that is your cis molecule. COH group are at the same side. Okay, this is at the top of the plane and this is also the top of the plane. Okay, this is top, this is also at the top plane, same side. This is a cis 1,2 cyclohexane carboxylic acid. Okay, and its second isomer is also like that. Okay, after rotation the equatorial will be axial and axial becomes equatorial. Okay, this is the cis isomer, both COH group at the same side. Second isomer, trans isomer. Okay, we can discuss the trans isomer. In the trans isomer, it is also having two types of isomer. COOH is there and COOH is there. Okay, this can be is also converted into our other form, that is equatorial after flipping becomes acyl become equatorial. Okay, remember that. This is the at the below the plane, and this COC at the top position of the plane. Okay. When we try the dissociation of first dissociation means any one hydrogen can be gives, any one carboxylic groups give the H plus ions, any one carboxylic give the H plus ions. Okay, one and both both these isomers can be give the our that particular dissociation. If it dissociate like that, in this case also it dissociate. First dissociation means the first hydrogen is removed. The first dissociation, it is called as the first dissociation, and it is having the certain value, pKa value. And for this molecule, one and the same, it first dissociation of this molecule, you found that first dissociation is there. In this case, this conjugate base is obtained from this acid. Okay, first dissociation. In this case, it is a first dissociation. In this case, it is also the first dissociation. It is having the pKa first value. pKa first value. When you compare these two molecules, okay, this it is also one of the isomer from this. It is also dissociates like that way. When you compare these dissociation of this with this, you found that this conjugate base is most stable. Okay, we are comparing these one to, because we are comparing this difference between this pKa value. Okay, difference is the pKa is the 2.42 and for this 1.75. Now this is the most conjugate base than this base. Okay, we are than this base. Okay, we are comparing the cis isomer with the trans isomer. Why this conjugate base is the stable one? We previously discussed that when a conjugate base is the stable, the acid is the strong. Strength of acid is the strong. Strong means it easily dissociate. Easily dissociate means it gives the easily H plus ions. Okay, therefore its conjugate base is stable. Therefore this molecule is the strong acid. Therefore strong acid means the less pKa value, less pK1 value for this molecule is this. Why this conjugate base is stable than this conjugate base of cis than the trans conjugate base is stable than the cis conjugate base. Why it is possible? Because it forms the hydrogen bonding. In the first case, in the cis case, it forms the hydrogen bonding. Okay, hydrogen is attached with the electronegative atom, which is itself also attached to the electronegative atom. This is the hydrogen bond. Remember that when there is a hydrogen bond, hydrogen in both sides attached to the electronegative atoms, and hydrogen bond is the weak electrostatic force of attraction. This is not actually bonding, it is just electrostatic attraction is there, because this near oxygen is electronegative, gets the delta positive charge. Delta positive means the very less charge, because the electrons from the hydrogen is moved towards or pulled by this oxygen. Therefore it has the delta positive charge. That delta positive charge and the negative charge there is a very weak attraction is there. They attract, charges attract and form the hydrogen bonding. And why there is a hydrogen bonding is happen? Because these groups and these groups are the same side group. Okay, this remember like that you show the like that. Okay, this is a okay like that way you can show that because it is excellent. Okay, you can it not excellent, it was the excellent. Remember that things. Okay, correct these things. There is a hydrogen bonding is formed. And therefore, due to hydrogen bonding, this gets additional stability. Therefore, this conjugate base is the stable than this conjugate base. Because in this case, these hydrogens and this oxygen is away from each other. Why away from it? It is a trans one because COH group is at one is the bottom side, one is that top side, one is that bottom at the plane to the bottom, one is that okay like that way these are the away from each other, one is upper side and other is the down side. Therefore these two groups are away from each other. Therefore in this case no hydrogen bonding is possible. Therefore when you compare, this is the less value and this is the higher pKa first value because we are comparing this with this. When you comparing this first dissociation is very easy happened in this our cis isomer, but in a trans isomer first dissociation is the not much easier than this compound. Therefore the second dissociation, for the second dissociation it is a difficult for this molecule to dissociate. Why this is difficult? Because we have this example. When it dissociate, it gives the, if you suppose it dissociate, it gives the like that charges is there. Okay, if second dissociation is second dissociation, that is pK to A values. Second dissociation in a cis isomer is the very difficult thing because after dissociation the negative charge on oxygen, negative charge on second oxygen, they are repulsion, that is the dipole repulsion or the charges repulsion is there. Therefore because these are the same side, so these groups are the same side, if the same it gives the H plus second molecule, second carboxylic acid when give the H plus, negative charge will be there and there is a dipole repulsion takes place there. Therefore this molecule is the after the second dissociation the conjugate base is the unstable base. This is the conjugate base is unstable base. Why it is unstable base? Because there is a negative charge is repulsion is there because both carboxylic ion are the cis to each other same side. Therefore there is a repulsion takes place and that molecule becomes unstable. Therefore this conjugate base is unstable. Therefore this acid is a weak acid. This acid is the weak acid. If your conjugate base is unstable, its conjugate acid is the weak acid because it not weak. When that molecule found that our conjugate base is the unstable, therefore it dissociates in less quantity. It try to remain in stable state. It not try to goes to the unstable state. Therefore it not use the more quantity H plus ion. Therefore its dissociation is the less quantity. Therefore if it is a weak acid, therefore pK value is higher. First pK value is the less and second is the higher. In case of this molecule, the second dissociation, the obtained conjugate base second dissociation for this molecule, second conjugate base you obtain You found that these negative charges or these are also away, these carboxylic ions are the away from each other. Therefore, there is no dipole repulsion is there, no negative charge because these carboxylate ions are the away from each other. Therefore, when compared to this, it is strong one. It is this is the strong acid, and this is the stable conjugate base. Okay, this value is very higher value. This pK value will be very higher because this structure is very unstable structure. Therefore, difference between pK and pK2 is very high. It is to be 2.42. And in this case, the second dissociation pK value is less because it is a strong acid. Okay, therefore the difference it is both are the both things it is somehow not much more unstable, both conjugate base, but in this case the second conjugate base is the very unstable and it increases the higher value of pK. Higher value of pK is the weak acid, therefore the pK value hence is increases in cis isomer. Difference between pK in cis isomer is the much more higher than the trans isomer. This is the one of the example. By using this example, there is a steric crowding is there in cis isomer. There is a steric crowding. Trans isomer there is a less steric crowding is there. By that way we can explain or we can give the conformation which acid is there by comparing its strength. We can give which conformation will be there. Thank you very much.